Okay, problem 15 on the problem solving says how many triangles are in this figure. And it's a bunch of triangles that are stacked on top of each other to kind of make a big giant triangle. So the bottom row has 7 triangles, and they go like teeth in a gear. So like one triangle up, one triangle down, one triangle up, one triangle down, one up, one down, one up. And they're touching each other. So they're shoved together. There's no space in between them. Above them would be triangle up, triangle down, triangle up, triangle down, triangle up. So 5 on that row. Above those would be triangle up, triangle down, triangle up, and 3 in that row. And then the very top would be a triangle going up. And all of these stacked on top of each other make a giant triangle. So there's all those little triangles that I just described, but then there's kind of medium-sized triangles that you can make by shoving those triangles together. So there's like triangles that are made out of 4. There's triangles that maybe are made out of 9. So again, lots of triangles that are inside that big triangle. Number 16, the first one, the first shape is just 1 square. The next one is 5 squares in a plus sign format. The next one is 3 by 3 squares, and then kind of like a tail on each end in the middle of the square. So you have a square that's 3 by 3. Off each end is a square coming out. And again, perfectly symmetrical. The next one is kind of that same shape. So it's kind of a diamond-y shape with like little jagged edges because it's made out of a square. But the easiest way to describe this is I'm going to go up and down in kind of like columns. So it's 1 square, then 3, then 5, then the very middle is 7, and then it goes back down 5, 3, 1. So again, all of these kind of make a little diamond-y shape, but because they're squares, it's kind of jagged. The pattern below has 3 squares on the bottom and 1 on top. Then the second shape has 1, 2, 3, 4, 5, 6 on the bottom, then 4, and then 2. And again, this is all symmetrical. So 6 on the bottom, the 4 are lined up so that there's kind of like 1 peeking out on each end. And then the 2 is lined up on the very top, again, symmetrical. So there's kind of 1 peeking out on each end from the row below. And then the last one is 9, and then 7, and then 5 and 3. And again, all symmetrical. So almost like stair steps when you can climb up the steps and back down, kind of like in wrestling, the podium where they climb up and the winner's on the top, and then you climb down the other side and they rank it. So it's kind of like a stair steps up, stair steps down is kind of what that is. All right, I'm going to pause here and I'm going to go to some other things that are in this folder. Okay, so this one says that imagine you're a member of a small tribe that lived thousands of years ago when people were making the transition from being hunter-gatherers to becoming farmers. You have a numeration system that is alphabetically based, so you are called alphabetians. Like many other ancient people, your numeration system is finite. For any amount greater than z, you have no symbol. You just call that amount many. And it shows a chart of what alphabetians thought. So 1 dot was an A, 2 dots next to each other was a B, 2 dots with 1 on top was a C, D was dot, 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 like 4 on a die where they make a square with the 4 dots, that's D. E is like 5 on a die where you have the 4 corners of the square and 1 dot in the middle. And then the pattern keeps going, you know, so that I don't visually show that. So E, then F, then G, and then it just dot, 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 Z is many. All right, and then now that your tribe has settled down, you have many sheep and many ears of corn. Without an adequate numeration system, figuring out how many more sheep you have this year than last year and determining each family's share of the corn harvest are very tedious. A young woman in her tribe has excitedly announced that she has invented a new counting system which she can represent any amount only using the symbols A, B, C, and D, and a new symbol she calls 0, and she writes as a 0. Unfortunately for your tribe, this young woman died on a hunting trip. The tribal leaders were very upset. They didn't want this wonderful skill to be lost to the tribe. The tribal mothers went into the woman's cave to get some articles for her burial. They were amazed at what they found. The woman had not just been gifted quantifier, she made wonderful cave paintings. The walls of her cave were covered with pictographs of bison, arrows, plants, and other items important to the tribe. Under each set of pictures was a deerskin. On each deerskin was a strange collection of blocks. Upon closer inspection, the mothers noticed that on each skin she had painted some symbols. So number 1, there's a picture of 6 bison. And then the deerskin contained, and there's 1, 2, 3, 4, 5 kind of glued together in a tower, and 2 individual single blocks. So kind of like base 10 single blocks, except there's 5 in a tower with 2 singles blocks. And underneath that is the symbol AB. Number 2 is a picture of, let's see, a bunch of turtles. And so it looks like there are, 58, I think. So 58 turtles. And then underneath it, the blocks, she draws a 5x5 square with little square things like base 10 blocks. So a 5x5 made out of 25 little squares. And then a tower with 5. And then 3 individual singles. And then a 5x5 square again shape. So kind of a square shape 5x5, 5 in a tower, 3 singles, and a square shape that's 5x5. And underneath that, she wrote BAC. So that was the number BAC to her, or to her people. The next one has a picture of 13 flowers, so that she drew 13 flowers on the wall. And underneath it, there are 2 towers of 5 blocks with 3 singles. And so 3 single little cubes. And so on the skin was written the symbol BC. So that stood for the number BC. Then there's a picture of a boatload of arrows. Let's see, how many are there here? 61. Okay, so there's 61 arrows. And underneath that, she wrote BBA. So to her, that was BBA. Let's see, the next one. This is problem 5, by the way. Sorry, problem 5. Again, a bunch of arrows. And looks like this time there are 53. And she has a square that's 5x5 of the little squares. So 5x5, 3 singles, and another square that's 5x5. And that's how many little blocks she used. So a 5x5, 3 singles, and a 5x5. And the symbol is B0C. So B0C is the symbol, which is the number that she represented there. And then 6, the picture's a bunch of stars. And this time, oh boy, let me think. I think it's 95. Let me do my math again. I'm kind of doing this in my head. Yeah, there's 95 stars. And so she drew a 5x5 square, 5x5 square made up of little base 10 little cubes. So 5x5, 5x5, and then 1, 2, 3, 4 towers with 5 in them, and then a 5x5 square again. So 5x5 square, 5x5 square, 1, 2, 3, 4 towers that are 5 high, and then a 5x5 square, and the symbol is CD0. So she considered that CD0. All right, so the tribal leaders knew this represented a powerful form of magic. They remembered the stories of different fires made to their tribe. They decided the tribe needed a new quantifier. This person would be powerful like the shaman. The tribal quantifier would be served first after each tribal hunt and would get their choice of caves. Tribal leader decided to allow each adult to go into the cave for 30 minutes, and they were examining the artifacts and pictures. Each person was to try to figure out the woman's scheme. The person who could best explain the scheme was to be the new quantifier. Your job is to examine the pictures, symbols, and artifacts, use the clues to deduce the woman's system. Imagine that you need to present the system to the council of elders. Carefully plan what you will say and how you will represent the system. Luckily, archaeology students from Iowa State went to this island this summer and brought back an artifact. Don't worry, the careful watch them. You would never guess they're 8,000 years old. All right, and then question 1 has, I don't know, a picture of maybe a Y with 2 dots above it, so I don't know what that's meant to be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 objects, and question 1 says, how would you draw the block representations for this group of objects? So this is in part 3, and there are 19 objects, and so how would you draw the blocks, like when she puts them in blocks? Okay, number 2, draw the block representation corresponding to the symbol BCD. So what would she draw, or that these people draw for BCD? What would that look like? Number 3, if you have 4 symbol numbers, such as BDCA, how would you represent this artifacts? Okay, and you might have to create a new logically consistent artifact, so something that she hadn't drawn yet. 4, how would you explain the procedure for writing the symbols for a group of objects as if you were explaining the procedures to your roommate who is not taking 195, or in this case 114? And number 5, in number 5 of part 1 on the previous page, Sally says the answer is BOC, or B0C. I see 2 flats and 3 units. Why isn't it just BC? Why did she need to put the 0? Right, and then for additional practice on part 4, number 1 says, state the symbols that correspond to each set of artifacts, and it's a 5x5 grid, 5x5 grid, tower of 5, tower of 5, tower of 5, tower of 5, and then 3 singles. B is 3, I'm going to call them longs instead of towers, because eventually we're going to switch to that language. So a long of 5, long of 5, long of 5, and then instead of square, I'm going to switch to flat, a flat that is 5x5, and 2 singles. C is a flat 5x5, another flat 5x5, 4 longs that all have 5 in them. D is a flat 5x5, 3 singles that are individual, a long that is 5, and then a 5x5 flat. So a flat, 3 singles, a long, and a flat. Okay, question 2 says, draw the artifacts for the following. You do not need to draw it all in all the lines, but make sure you can tell one artifact from another. So like flats from longs from singles. So A, this is question number 2. A is ABC, B is CBA, C is AB0C, D is A0BD. And again, I don't think we'll get through all of that, but the main idea is the first part, like when you're trying to discover what these people are doing. Okay, so I'm going to stop there on that one.